What I want you guys to do right now, so again, today's learning target, our learning target is that you can identify a set of data points or graphs as a function versus not a function. So what I want you to do is take a look at these examples here. These all are examples of what a function is. And then down below, these are all examples of what is not considered to be a function. So notice I gave you two examples of kind of what looks like a Venn diagram. It's not quite a Venn diagram, but it's a map. We call that a mapping. So here are two examples of mapping that are considered to be functions, two examples of mappings that are not considered to be functions. I have a couple of examples, 4 examples of graphs that are considered to be functions, some examples of graphs that are not functions, and then 2 table examples of functions versus 2 tables that are not functions. I want you to identify key characteristics that make this information a function and this not function. So go ahead and take a few moments, give you about 5 minutes to kind of go through this on your own and see if you can identify the characteristics. Okay, let's take a look at these again. So for the functions, the ones that are functions, remember when we're talking about functions, we're talking about domains compared to ranges. For these examples here, the left side, this left side is considered to be our domain, which is our x values, our input. The right side is considered to be the range, which is your y values, your output. Again, same thing here. This is your domain on the left side, which is your x. These are your range values. Those are your y values. That's your output. Okay, when we're taking a look at the graphs, we've got the graphs that are, are they straight? Are these straight lines? No. Is this one a straight line? Yes or no? Is this a straight line?
Yes.
Yes. Is this a straight line? Yes. So, is that a straight line, Mario? Is that a straight line?
Oh yeah.
Yes. So it has nothing to do with whether it's a straight line or not. So we don't need to worry about straight lines versus not straight lines for a function. And then again, with these tables here, this is considered to be our x values. These are your y values. These are your x's. These are your y's. Okay, so when we're taking a look at it, what is one thing that you noticed about the ones that were functions compared to ones that were not functions? Hassan?
Domains, which are the x values, they don't repeat in the function examples, but they do in non-function examples.
Very good. So the domain in our function example, so if I zoom in here, these are examples of a couple of mappings showing a function. With my domain, each of these domain values has exactly one branch that's coming off of it, doesn't it? Okay, -4 branches only one way. -2 has only one branch. 0 has one branch. 2 has one branch. +4 has one branch. Okay? This example, same thing. The domain, each of these domain values only has a single branch. Notice the range, though, has multiple, doesn't it? Like 16, with 16, we've got 2 that are extending towards it. We have 2 domains that are connecting to it. It's a -4, 16, and a +4, 16. Same thing with the 4. -2 connects to the 4, a +2 connects to the 4. And that's still okay. The domain never has more than one branch coming off of it. The range might only have one branch connecting to it. It might have multiple branches connecting to it. When we look at our non-functions, again, this is your domain. This is your range. For here, this then becomes not a function. Why? Which one of the domain values is going to create it to no longer be a function? Jeffrey? The 5. If we take a look at this 5 has 2 branches extending off of it. That right there, this case, is what makes it no longer a function. Okay, same thing with our second map that we've got. Here's our domain. Here's our range. Which value up here for the domain creates it to not be a function anymore? Amy? The 1. Okay, that positive 1 has a branching that goes to a 0. I don't know why they put a negative there. And then a 15. It branches to the 0 and it branches to the 15. That right there is going to create it to no longer be a function because the domain has more than one extension. You cannot have more than one. So it's a very important rule to understand. Now, let's go ahead and compare the graphs. Taking a look at our graphs, yeah, this graph kind of loops. This graph loops once. This graph is straight. This graph is straight. Those are all considered to be functions. But now if we look down here at this graph and this graph, what do you notice about these two graphs that's different than the function graphs that we have up here? Fatima? Okay, one of them is a closed shape, right? Like a circle. Okay. One of them closes. This one doesn't close, though. Why is this still not considered to be a function? Hassan?
There's an intersecting point,
There's intersecting points. What do you mean?
like the lines connect.
Okay, so these lines connect. They kind of connect here, too. At some point, they connect down at the bottom. Okay, but there's a difference here. Let me explain to you something that's called a vertical line test. So I want you guys to write that down. The vertical line test. With a vertical line test, I can draw a vertical line. Vertical lines go up and down. I can draw a vertical line anywhere I want on my graph, and it should only cross over the function or the relation at one point. So in order for the vertical line test to pass, it should cross only one point on the relation in order for it to be considered a function. So it doesn't matter where I draw my vertical line. If I draw my vertical line right here, I'm going to zoom in so that you can see it a little bit easier. If I draw my vertical line right here, I cross the relation only at one point. If I draw it right here, I'm going to cross my relation only at one point. I can draw it here. I cross the relation at just one point. It does not matter where I draw my vertical line. I'm only going to cross it at one point. Same thing for here. If I cross my vertical line, I cross it at one point. Even if I go all the way down the axis, it only hits the relation at one single point at the bottom. It does not matter where I draw this vertical line. The vertical line crosses the relation at one point. Taking a look here, a nice flat horizontal line. Obviously, I'm only going to cross it at one spot no matter where I draw my vertical line. Okay, here, 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 here. That vertical line will only pass it at one point. Same thing on this one. Here, here, doesn't matter, here. Only going to cross it at one single point. Now, obviously, if my relation is a vertical line, is it going to pass the vertical line test? If it is a vertical line, it won't pass, right? Because if I draw a vertical line on top of that vertical line, it's going to pass it at every single point. So a vertical line is not a function, but a horizontal line is. Now, if we take a look here at these examples of what was not a function, draw a vertical line anywhere. If I draw a vertical line right here, how many points did I cross? 2. 1 point, 2 points. I cross it at 2 points on that relation. Okay, if I draw it here, I'm going to cross 2 points on that relation. So at any point, if you are able to draw a vertical line and cross it at more than 1 point, it's not a function. So the goal is for you to see if there is any place that you can draw the vertical line that will cross at 2 points. If it can, then it's not a function, because it doesn't pass the vertical line test. So anytime that we're looking at a graph, if we're looking at a graph, it has to pass the vertical line test. If it doesn't pass the vertical line test, it is not considered to be a function. Okay, and like I said before, here I'm going to draw another little graph off to the side. If there is at any point a vertical portion, so like let's say that we have, I'll draw it in blue. Let's say it goes like this, and then all of a sudden it goes straight up, and then goes here. Okay. At this point, this does not pass the vertical line test. Okay? It does not pass. Okay, so you have to have it pass that vertical line test in order for it to be considered a function. Okay, and then looking at actual specific points, looking at a table or a series of like ordered pairs, that's an easy one to see. Do any of my x's repeat? In this first one, do any of the x's repeat? No. None of these x's repeat. Okay, look at the second one. Does any of the x's repeat? No. Okay, do the y's repeat? Yeah, some of the y's might repeat, and that's okay. It's important to understand x cannot repeat. Your x cannot repeat. If your x repeats, or if your domain repeats, then it's going to not be a function. You do not want to have any repetition for your x. Y is allowed to repeat. The y is allowed to repeat. That's perfectly fine. So if we take a look down here at the non-function examples, again, this being our x, this being our y, we have a repeat right here of an x. We have a 1 and a 1 with different y values. You cannot have the x repeat and have different y values. Same thing for here with this input, which is your x, and your output, which is your y. You have a repeat with the 4 when your output is 7, and a 4 when your output is 14. Not allowed to happen. This makes it not a function. Okay, so based off of that information, go ahead and flip it on over to the back. We're going to write down a couple of rules that you need to make sure you know when determining whether something is or is not a function. Leah, I'll give this to you. Okay? When determining whether something is considered to be a function versus not a function, rule number 1, the domain, which is your x. Okay, your domain, your x, or your input, cannot repeat. Okay, it cannot have more than one range. And I'm going to highlight cannot in pink. Okay, just making sure you understand. It cannot repeat. The domain, the x values cannot repeat. It cannot have more than one range value. But I'm going to put a little star here, a little side note. Remember, the range can repeat. The range, which is your y, or your output, can repeat. It doesn't always, but it is allowed to. The range is allowed to repeat. You're allowed to have a repetition for your range, but you just can't have that repetition for your domain. Okay, and then example number 2, or sorry, rule number 2, if we're looking at it graphically, the graphs must pass the vertical line test. The graph must pass the vertical line test. And I'll even draw a description again, or write a description in case you need to remind yourself. When drawing a vertical line, it can only pass through the relation at one point. So it does not matter. Wherever you draw your vertical line, it can only pass the relation at one point. If you can physically draw a vertical line that passes through more than one point on that relation, then it's not a function. Jeffrey? Oh, thank you. Thank you very much. When drawing a vertical line, it can only pass through the relation at one point. Richard, turn around. The board is in the front, not in the back. Okay, so what I want you guys to do right now for problems 1, 2, 3, and 4, you are going to identify whether those are examples of a function or not a function based off of what we just stated here and based off of the examples that you've seen. Identify if it is or is not a function. If it is not a function, please identify where you are able to see it not be a function. Identify where the x might repeat, or identify where the vertical line might pass through more than one point. You need to show me where were you able to spot that it is not considered a function. So let's take a look. For problem number 1, is this considered to be a function or not a function? Not. What value, what points make it not a function, Asia? Okay, so there's the x repeats, right? There's 2 2's. We have this point, 2 6, and this point, 2 4. So the fact that the 2 repeats with a different value of the y, that makes it not a function. So we're going to put down that the domain repeats. The domain repeats. It is not a function. What about for problem number 2? The mapping down below. Problem number 2. Is it a function or not a function? Zachary? Which value? -1. Good. So the -1 has 2 branches. That -1, which is your domain, has 2 branches. This is your domain. And because it has 2 branches right here, that makes it not a function. Okay? In order for it to be considered a function, each of the domains can only have a single branch. What about problem 3? Is it a function or not a function? David? Function, right? Each of these domains has only a single branch coming off of it to the range. Now it's okay. The range has more than one branch. That's fine. This is considered to be a function because the domain each has only one branch coming off of it. Okay, what about for problem 4? Function or not a function? Charlie? No, not a function. Why? Yeah, how many points will it actually cross through if you do a vertical line test in a certain spot? Kai? 3, right? Right here, if we draw our vertical line test, it's going to go through these 3 points. These 3 points it's going to cross through. So it does not pass. That is not a function. Okay, any questions about identifying whether it's a function or not? It's pretty simple, pretty easy stuff. You have an IXL or 2 IXL skills for functions versus not. They're quick and easy.